All right, in section 1.1, we took a look at models that were all exponential population models. If we had a positive growth rate, that would be exponential growth, and a negative growth rate would be exponential decline. In section 1.2, we go a step further, and we have populations that are maybe growing exponentially or declining exponentially, but in addition, there's some intervention that we're performing on the population. In the case of the sandhill cranes, we are adding members to the population every year, and that's known as stocking. Well, in the case of the cranes, it's called hacking, but in general, it's called stocking. And in the case of something like the white-tailed deer population, we're removing members of the population every year through harvesting. So when you have those two effects at the same time, either exponential growth or decline and harvesting or stocking, we have what we call an affine model. And so the content of this little Excel help video is to construct the affine model that would then apply to all of the situations that I just mentioned. So once again, we start with a title. I'll type it into cell A1. And then, as will be our habit, any model parameters we'll store in their own cells so that we can experiment with them easily later. And then when we go to create the formula or the equation for the model, then we'll just refer to where those parameters are. We'll use our absolute addressing, so that means we'll use dollar signs around the cell addresses for parameter values so that when we copy formulas down, those cell addresses don't change. All right, well, we have two parameters in an affine model. One is the growth rate. I'm just going to give a stand-in value here, let's say 7%. And the other is what we have called little a, and that's the stocking or harvesting number. In this case, let me just give a stand-in value of, say, 10. So that would indicate a population where we're adding 10 members to the population every year. We have the same two columns to keep track of. Time, which is in years at the moment, since the start of the problem, and then the population, which starts at the initial population and then changes over time. So t starts at 0 always. I want to increase t by 1 every year, so I refer to cell A7, add 1 to it, drag that down with the thin cross, left click and drag. All right, so I've covered 9 years of population change. Let me say that the population here starts off at 100. This is just a made-up stand-in value. That this value would change if you used this spreadsheet to do one of the homework problems, for example. Okay, so the affine population DDS, remember all DDSs start the same way. The population in 1 year equals population the previous year, right? So that always starts off the same way regardless of the model. And then to that, we know the population is going to change by R% each year. So I click on the growth rate, I put dollar signs around it so the Excel doesn't change the location of that parameter, and I multiply that times the previous year's population. All right, well, if I stopped there, I would have the exponential growth model, but this is an affine model, so we have to also account for the fact that we're adding 10 members to the population every year. I'll do that by referring to cell B4 where the 10 is stored. And this is another parameter that I don't want the cell address to change for. So put the dollar signs in. I'm hitting F4 to do that automatically. You could also type them directly into the formula if you wish. So previous year's population plus R% times the previous year's population plus the 10 for the stocking number. You can hit enter and then copy this down either by dragging or do it the shortcut way, double click, and it'll just copy it down to the length of the nearest column or the adjacent column. Right, I had already rounded in a previous exercise, and so when you copy down, these may not have been rounded. So let me go back and show you how to round. I know we did that in the last video, but these buttons here control how many decimal places we see. So if you wanted to see out to 3 decimal places, you can click until you get exactly 3 decimal places, or you can decrease the decimal until you have whole numbers, which will, in this chapter, we'll typically have. All right, so I've got my affine model is all set up. We're free to use either positive or negative values for r, indicating exponential growth or decline. We do a decline of, say, 0.05. And we can have either stocking or harvesting, and so a positive value here indicates a stocking of 10 members each year, but we could be harvesting members, so let's say I enter a -5, then not only is the population decreasing on its own, but our intervention is causing it to decrease faster. So we would lose 10 the first year, 9 the second year, and so on. These are rounded values, of course. Okay, so one thing you might do, just kind of depending on how you want to use these and if you like to have a reminder, but it might be helpful to include next to the parameters a little bit of information about them. So you could type, this is the growth rate, positive for increasing, negative for decreasing. And you could mention that this is the harvesting or stocking number, positive for stocking, negative for harvesting. This sort of thing isn't necessary, but it's sometimes helpful when you go to open a spreadsheet that you haven't thought about for a while. It's helpful to have a note like that reminding you what it is you were up to. So that's going to do it for the affine model. All right, so I will post this Excel file and video on Moodle for you. Hopefully these will be helpful for you to learn the Excel techniques and also to know that you've got a working version of the spreadsheet available to you, though of course at some point you will be asked to make one yourself. All right, so that'll do it for this video, and I will see you next time. Thanks.